All right. So we're going to talk about how to graph these equations. Oops, forgot to change this thing. It's got a couple names. The generic way of calling it would be rectangular coordinate system. I could call it either one. Or I could call it the Cartesian coordinate system. It means the same exact thing. By the way, the makeup tests, the redo thing, that's it. No more this year. Okay, so whatever you get, you get. Just letting you know. This is not a thing that I normally do. All right, giving you a retake test. All right, that's the last time I do it the rest of the year. Everybody understand that? All right, so you guys are acting like you can do whatever you want. Think of what your first test was, and then think about your behavior today already, and think about what might need to change. I think what might need to change is that some of you that did so poorly the first time that kind of forced me into doing a retake need to evaluate where you're at here. Okay? So that means you should take notes, you should listen, you should stop trying to make this dumb, stupid jokes, all right? Making everybody laugh. Hilarious. Get it? Everybody laughs at you. Okay? You're a clown. Congratulations, you're a clown. Okay? Is that going to help you on these tests? Is that going to help you pass this class? Is that going to help you get into college? Is it going to help you in college when you take a class just like this and you don't know what's going on because you never paid attention this year? All right? So think about those things. You guys see this far into the future right there. Okay? I see way, way beyond because I've been there. I'm way, way beyond my high school days. I see what it takes. Okay? You asked me before, when are we ever going to use this? Da-da-da-da-da. You know what? It doesn't matter. Okay? Just pass the class. Just learn the material. Okay? There may be a time where you look back and you're like, you know what? I'm glad I learned that stuff. You need to stop talking. There may be a time when you look back and you're like, man, I'm glad that I did learn that stuff because it really helped me in whatever situation. Okay? It may not be a real life situation. I'm not going to try to blow smoke and say, everybody's going to use this stuff every day of your life. You're not. Okay? Some of you may never use this again the rest of your life. Okay? But you know what you're going to use? See, they didn't totally break me. I'm going back into my teacher thing here, my trying to encourage a thing. You know what this helps you do? This helps you learn not just to solve math problems, but just it teaches you how to learn. This is a class that barely anybody in here wants to be in, okay? Either it's way too easy for you because you've had this stuff before, or you never learned it before and it's too hard and you're just not even going to try, okay? I think there's two camps. I think that's basically the two camps. Maybe a few people in between those, okay? But what this is going to do, it's going to take something that you don't really want to do, and it's going to teach you how to learn something that you didn't really want to learn, but you did it anyway. You know what life is? Life is full of that. Life is tons and tons of that, okay? It's so many times in regular life where you got to do something, you got to learn something, and you don't want to do it, but you have to do it. And this is one of those situations. You learn how to deal with it here, and it's going to make it easier when you get out in life. You're going to look back on things like this, not just this class, but other classes like this. You're going to look back and you're going to say, man, I really didn't want to be in that class. It wasn't any interest to me, but I did it. I fought through it. I worked hard. I accomplished it, and I finished it. okay? You still might not even like this stuff when you're done, okay, doing it. I get it. I understand. I've been there. But looking back on the things that I did that were difficult, that were hard, it really prepared me for other things that happened in my life. And that's what this can do for you. I'm not going to tell you that you're going to use this all the time. Some of you might. I've had a lot of students come to me. I had somebody just the other day. I shot their family pictures, husband and wife. I taught the husband, the dad, and it was in this room right here. I actually taught math in this room a long time before I was doing the media arts stuff. And he sat right in that first seat right there, I remember. And he said he didn't like it at all, but he learned it. And he said he actually, I don't know what he does for his job, but he actually uses a lot of the concepts that he learned in here in his job. I mean, not everybody's going to say that, but he looked back on that. He's got 2 kids now and pregnant with the 3rd one. And that's why I was taking their family pictures. And that's what they said. You just don't know how many times people have come back to me that were just a pain in the butt when they were in high school. And they come to me and they say, Mr. Hamrick, I want to apologize. And I didn't ask them to. I see them somewhere in church or in a store or I don't know, somewhere out there at a game. And they'll come up to me, yo, Mr. Hamrick, how you doing? And I thought this kid hated me. And he probably thought I hated him, but I didn't. All right, just didn't like his behavior. But I've had tons of kids come to me. Well, they're adults now, married, families. And they come to me, Mr. Hamrick, thank you so much for doing what you did because it really helped me. You know, I really struggled with your class, but I worked hard. That helped me when I went to college because I had classes in college that were really hard and I struggled with. And I knew that I could do it because I did it in your class and I did it in my college class, okay? Those are the things that you can get from here. Those are the things that you can take away from this, okay? It may not be the math itself. That's really not the important part, okay, for a lot of you guys. For some it is. I've had kids that graduated, or that had my classes, graduated, become engineers and everything else. And doctors. I've had doctors that I've taught that are actually medical doctors. I'm not saying they're a doctor because of me, but I've taught kids that have really accomplished a lot of things like that. And I just want you to be in that position to do the same thing. That maybe you'll come back and you might even apologize. I'm not asking you. I didn't ask that kid for an apology, but he just came back. He felt like he needed to apologize to me because of the stuff that he put me through. I'm in the middle of talking. The stuff that he put me through, and he did. I remember this kid, man. This kid put me through a lot. This is actually when I was teaching in Newcastle. His name was Brandon. And he actually went to Red Lion. And Red Lion stopped in 8th grade. And a lot of those 8th graders would come to Newcastle where I was. And we'd take a lot of the Red Lion kids because we went all the high school and they only went to 8th grade here. And he was one of those Red Lion kids. And he was like one of these spoiled, pampered kids and whatever. And he was a pain in the butt. But he worked hard in my class, eventually. And he did really well. He went into the Air Force, or he went in some service or something like that. And I think he actually went to Afghanistan, he went to Iraq and all that kind of stuff. And it's amazing, and when I looked at that kid in high school, I thought, man, this kid doesn't have a chance. He's lazy, has no interest in anything. He just didn't want to do anything. He was the class clown, wanted to make everybody laugh, all that kind of stuff. All right. But he did get stuff out of my class and he did learn stuff. And he came back to tell me that as an adult. And I would have never known any of that stuff. So it happens, believe me. So when I put up with your nonsense, I've put up with it before in the past, and there's still hope for you. All right? There is. There's hope for you. But you got to turn it around at some point. At some point, they turn it around. Now's the time to turn it around. Okay. I didn't mean to record all that, but I'll keep it on there. I don't care. All right. So let's talk about this thing right here. All right. So the Cartesian coordinate system, the reason it's called Cartesian, it's kind of a weird word. Where in the world does that come from? It comes after a guy. And in America, we'd probably think he had a girl's name, but it's not. In France, it's a guy's name as well. So it's Rene. His name was Rene Descartes. I always thought the C was capitalized, but then I looked in the book and they didn't capitalize it. But it's not Descartes, it's just Descartes. The S is silent. So his name was Rene Descartes. I wrote it down. I would not have this memorized unless I wrote it down. So from 1596 to 1650. So this guy, He was known for a lot of things. He was a French philosopher. He was a French mathematician. I think he was a scientist as well. But he is known for this thing right here, this Cartesian coordinate system. And again, just generally, we call it the rectangular coordinate system. And I'm positive that you've worked with this before. And it's this thing right here. I'm going to copy it and paste it right here. Make it a little bit bigger so I can write on it. So this thing right here is called the rectangular coordinate system, or some people call it the Cartesian coordinate system. So let's go through some of this. A lot of this stuff you already know, but you're going to need to know it now. If you didn't know it before, now's the time to learn it. So you got these two lines, and they're perpendicular to each other. One is horizontal, one is vertical, and we have a special name for them. Do you know what the name of it is? It's an X and Y what? Axis, right. So this is an X-axis, and this is the Y-axis. You've done this since maybe even in pre-algebra. I don't know. At least in Algebra 1. I know for a fact that you guys all did this in Algebra 1, and then you did it in geometry, and you did it in Algebra 2, and here we are back doing it again. All right, so I'm going to start from scratch because I don't know a lot of your backgrounds. So this is where we're going to start. So an X and Y axis. By the way, what is the plural? If I said X and Y, is it axes or what is it? Axes, very good. So it's A-X-E-S. That's the plural for axis, all right? So singular, A-X-I-S, and then A-X-E-S, that's the plural for axes. All right, enough of that. It's broken down into 4 little sections, okay? You got this top right section here, you got this top left, bottom right. We have a name for that. You should know the name for that. What are those called? Quadrants, right. Quad meaning what? 4. Okay. And then, I don't know what the rant part is, but they're called quadrants. It's just an area. It's broken up into 4 areas. The first area, the top right one, we usually name it with Roman numerals, okay? So it goes the top right one, and then it goes, counterclockwise, all right? So that's the first quadrant, second, third, and fourth quadrant. It's just so that when we're talking about what quadrant a point is or what area a point is, everybody, we're on the same page and we know, okay, what area that they're in, all right? We also have another thing. We have an X and Y axis, and so we actually have points that could be on here. We've actually graphed a little bit earlier this year. Do you remember the first test where you had to graph? Some of you would like to forget it because you didn't do so well on it. Yeah, it was a number line, okay? A number line is a graph. And let me just go over a couple things that I don't know if teachers taught it this way to you or you just decided to do this on your own or what. I'm not really sure. But like if you had this, let's say that was at 0, 1, 2, 3, and then 1, 2, 3. And I said this was, where would this be? Where would that point be on the number line? Where would it be? It'd be at 1, exactly, all right? So remember we did this stuff where I said graph. So we've done graphing already, but now we're going to do a different type of graphing. Graph x is greater than negative 2. All right, so what if I asked you to graph that? Well, what if I said this? Let's do this one first. What if I said x was equal to negative 2? What would I do? I'd come over here to negative 2 and do what? Put a dot. Put a dot where, though? Right on the line. Right on the line, okay? So if it said x equals negative 2, we'd put a dot right there on it. Again, we talked about this earlier, but some people are doing like this, putting dots up there. No. We don't do that. We put it where? Right on the line, all right? So we put it right on the line. In this case, it's really not a dot. It's x. Let's do this. Let's change it. X is greater than or equal to negative 2. So here's negative 2. X, I want you to sit where you were. I don't want you sitting there. So your seat's going to be right where you were earlier. I don't know why you keep moving around. But so watch. If I said x was equal to negative 2, we'd put a dot right on the negative 2. I'm going somewhere with this, all right? If I said x is greater than or equal to negative 2, remember we would do this? We did it a little differently. We put that little bracket there, and then we shade everything to the right. Well, the stuff that we're doing now, we're not shading to the right or anything like that. We're not putting brackets. We are going to put some parentheses, though, all right? So what we're going to do is we're just going to find where one point is located. But the thing is, we're not just going along one axis. This was just along one axis right here. We're not just going along one axis. We got two axes, all right? So if I said I wanted to find out where that point right there is located, see that yellow point I just put on there? If I asked you where it's located, we all need to be able to say where that point is, all right? Because we need to be on the same page. A coordinate system is very important. The coordinate is basically, see where it says rectangular coordinate system? The rectangular is where the point is located. That's what coordinate means, okay? At what number is the point located? Where is it located? So if I put a point here, everybody should tell me how to get to that point. Well, we got to have a starting point. Okay, and the starting point is where those two axes intersect each other right there. That's where we start, okay? And we give it a name. Do anybody remember the name of the starting point? The origin, right. So this has been taught to you because you guys are giving me the right answers here. So that's the origin. That's where you start. It's where you begin. That's what origin means. So you start here, and we go in a certain direction first, and then we go in a second direction secondly. And we know that by this thing right here. All right, we put a parentheses and a comma in between. And then the first direction we go is in the x direction. Again, so we're on the same page. Everybody's going to start at the origin, and the first direction we're going to go is in the x direction. That's horizontally. And then we're going to go in the y direction. That's vertically. All right? And you could go positive, you could go negative. So before we actually do the point, let's put the signs in the first quadrant. Every single point in the first quadrant. If you start at the origin and at any point in this first quadrant, what are the signs going to be? So I have to go in the x direction. So how do I get to this point right here? I go to the what? Left or right? I go to the right. So what do you think that is? Positive or negative? It's positive. Okay, so I go positive. And then in order to get to any point in the first quadrant, now which direction am I going to go? I'm going to go up. So what do you think up is? That's going to be positive as well. Okay? So in the first quadrant, it's always going to be positive, positive. What's it going to be in the second quadrant? Start at the origin. I got to get to the second quadrant. I can only go left and right and up and down. So what do? I go left. Left is negative, and then I got to go up. Up is positive. What about the coordinates for the third quadrant? Negative, negative. That's right. And then the fourth quadrant, it would be positive, negative. Any point in that fourth quadrant, I go positive, negative. All right, everybody with me on the signs? Now let's do the numbers, okay? I got these little grid mark things there. Each one will count as a 1. So if I start at the origin and I want to get to this point, I am not going to go diagonally to get to that point, okay? Again, it's like, I don't know, it's a movie from the 80s. You ever see Tron? I think they did a remake of it, and they even have something in Disney, the Tron movie. So they can only go along certain lines, right? They have grid marks, and the guy on Tron, he's in some kind of like motorcycle thing or whatever, I don't know. And then he can go up, he can go over, up and over, down, to the left, to the right. He can't go diagonally, all right? So think of it like that. So if you start here and you want to go to this point right there, where do we go first? How many places? I go 3 places to the right. So that's a what? That's a positive 3. So what I'm going to do is I'm going to make an ordered pair. We call it an ordered pair because it has to be in a particular order. So it has to be in a particular order. We have to go in the x direction first, then we go in the y direction. So we start here, we go in the x direction, so we're basically just going to go to here, all right? So we go how far over? 3. It's positive because we're going to go to the right. And then we go up. Up is positive in the y direction, so we go 2, 1, 2 in the positive direction. So what is the coordinate of that point? It's 3, 2. I hope all the people with their heads down either already know this or will check the YouTube video. I'm sure you'll do both. Either already know it or check the video. All right, so here we go. What if I put a point, stick a point right there? Where's that point going to be? Let's take a look at it, count over. So let's count how many? 1, 2, 3, 4, 5, 6, 7. So that's negative 7. And then I go up how many? Same thing, but positive 7, right? so I go to the left 7, so that's a negative 7, and I go up 7, so I go negative 7, 7. So that's the coordinate of that point. Again, it's the signs that we said it was going to be, isn't it? It's negative, positive, just like we said. First one's negative, second one's positive. What if we lie, let's do a different color, getting too much yellow in there. Let's go to this pink color. What if I had a point that was right on the x-axis itself? All right, we still show the coordinate by an ordered pair. We got to go x and y. So again, we start at the origin, and we go to the left to get to this point. How many? 1, 2, 3, 4, 5. That's negative 5. How far up do we go? We go up 0. Mason, can you do me a favor? Can you shut off all the monitors back there, please, for me? Thank you. Like children. All right, so that's negative 5, 0. So when it lies on the x-axis, what is the y point always going to be? Like if I went over here, like if I put a point right here, okay, that's going to be 2, 0, isn't it? So the y is always going to be 0 because you don't go up at all, right? You only go to the x and you don't go up at all. So that's always going to be 0. That's something that we're going to talk about here in a little bit if we get to it. So that point would be 2, 0. Let's do another one. What if we did this point right here? Where's that? What's that point? What's the coordinate of that point? And that's what they're going to ask you. That's the question they're going to say. What is the coordinate of point A, or whatever letter they assign it, okay? What is the coordinate of point A? So we start at the origin, and we go to the left or the right. How far to the left or the right do we go to get to point A? We go 0. So we don't go anywhere on the x direction, so you got to put that in there. You got to put a 0. Then how far up do we go? 1, 2, 3, 4. So that point is going to be 0, 4. Okay? Just unplug that if that doesn't turn off. There you go. All right. I could ask you two things. I could give you a graph, put some points on there, and you tell me the coordinates. Or I could actually ask you to graph something. So what if I asked you to graph the point 3, negative 5? We'll call it point B. All right? So graph point B, and your point is 3, negative 5. So you start at your origin, and how far to the left or right do we go? Talk to me. Somebody talk to me so I know you're alive. All right, don't talk to me. So you go 3 to the right. So you start at the origin, and you go 3 to the right. So I go 1, 2, 3. But we don't stop right there. We don't put a point right there, but we do hold our pencil there. And then how far up or down do we go, Alex? We go down 5. 1, 2, 3, 4, 5, right there. I'll put a B so I know what point that's supposed to be. All right? So I could ask you two different types of questions for what we're talking about right here. I could give you a point on a graph, you tell me the coordinate, and then I could tell you to graph a certain point, and you've got to put it on the graph. All right? That's a little messy. It's got a lot of stuff in there, but I think you followed me. All right, what's the title of this lesson? It's graphing linear equations, okay? What word do you see in the word linear? In the word linear? I've had a lot of people say ear. That's right. You do see that. But what math word do you see in there? You see line, okay? So a linear equation, when you talk about something that's linear, you're talking about being a line or a straight line, okay? Straight line's kind of redundant because a line already means it's straight, but that's fine. I don't mind if you say straight line. All right, so that's what we're going to do. Now, back in pre-algebra, algebra 1, they showed you how to graph something very simple. And so here's what they're going to do. They're going to give you an equation. Remember, that said graphing linear what? Equations. And they're going to give you an equation with x and y in it. So this is not the one in the book. They give you a fraction in the book. I thought I decided to make it a little bit easier for you, just give you something really basic. All right, so y equals 2x plus 3. And if I was to ask you to graph this, now some of you guys would be able to graph this a certain way without doing any math, just putting 2 points, boom, boom, connect them, and you're done. All right? Who thinks they can do that? They can look at that. They know exactly where to put the 2 points. You graph it. Okay, 3, 4 of you. Okay, there is a way to graph it very easily, but I'm going way back. I'm going back in time to the first time you learn how to graph straight lines. Okay? There's a better way to do it. So the way I'm doing it right now is not the best way to do it, all right? But it is a way to do it, and it's a way to kind of understand what's going on. So what we do is this. Make a little chart. Do you remember doing this back in Algebra 1? You put an X. I'll take it. Bring it here. Thank you. You guys can pick them up from the office. All right, so we put an X and a Y. Put a little chart here. So what we're going to do, since Y is by itself, all right, we're going to choose some X's. Because what is this X and Y on our coordinate graph, our coordinate plane? Okay, it's our ordered pairs, right? They're points on a graph, just like we did. So, if I know what X is and I know what Y is, I can plot that point on my graph. I need people listening to me. Not everybody is. So if I know an X and a Y that go together, that fit with this equation, now that X and that Y, that X has to make this right side equal the left side, okay? I can't just pick out any X and any Y just randomly. But I can pick a random X, put it into the equation, figure what the Y that corresponds to it, that goes with it, okay? So I can pick just some random X's. I don't want to pick anything crazy and real difficult. Okay, so what we usually do is this. You don't have to do this, but this is what they usually do when they start. They usually start with a couple negatives, all right? So we'll start real easy. A couple negatives, a 0, and a couple positives. Now, how many points does it actually take? What's the minimum number of points that it actually takes to make a line? It takes 3 points to make a line? Only takes 2. Only takes 2. So I could just pick just 2 random points for X, and that'd be fine. It would work. It would actually work, okay? But I'm showing you what you learned back in the day. I want to show you that, because I could just pick any 2 points and it's always going to make a line. But how do I know if that line is the right line or not? Well, I pick an extra one, pick an extra point. Okay, get a third or a fourth or a fifth. If they all line up perfectly, then I know that I've got my line correctly. All right, so let's do it. Let's plug these in. What we're going to do, these are all my values for X. I'm going to plug in that X right here and figure out what my Y is that goes with that -2. All right, so let's put a -2 in for this. Can you do it in your head or not? I don't know. 2 times -2, right, plus 3. What's that? That's -4 plus 3, which is -1. So what goes with the -2? The -1. So this is an ordered pair. This is an ordered pair that looks like this. All right, and we're going to put that on our graph. We'll do that in a few minutes, okay? So we'll put that on our graph. So we're going to actually have, what, 1, 2, 3, 4, 5 points that we're going to put on there. And hopefully, if we did it right, all 5 of those points will line up to make a nice straight line, okay? So let's do the rest of them. Whoops. Let's put -1 in for this. Let's do it in our head this time. Put it in a -1. What's that going to give you? Excuse me. That's -2, right? 2 times -1. That's -2 plus 1. What's -2 plus 1? I'm sorry, not plus 1. Plus 3. -2 plus 3. I'm thinking of the answer. -2 plus 3 is what? 1. Okay, put in a 0 for this. 2 times 0 is 0 plus 3 is 3. Put a 1 in for this. 2 times 1 is 2. Okay, plus 3 is 5. Put a 2 in for this. 2 times 2 is 4 plus 3 is 7. Okay? So we've got our points. We could write them all down as ordered pairs. I'm not going to. I'll just keep them in the chart. Let's put this graph here again. Excuse me. Again, sorry. Let me just make it a little bit bigger. Okay, here we go. So let's plot these points. So the first point, I already wrote it down as an ordered pair, but it's -2, -1. So there's -2, there's -1. Put a point right there. Okay, let's change that to a different color. Let's go blue this time. Okay, so there's our point, -1, 1. So you start at the origin, you go -1, you go up 1. Now, I could stop right there and connect those points, and I should be good. But I want to put a few more in there just to guarantee, just kind of make sure that I got the right line. Because you could put any 2 points. If you made a mistake, you might have put a point here and you would have had your line going this way. All right, but let's put at least 3. In this case, we'll put, 5 of them in here, okay? So 0, 3, where's 0, 3? 1, 2, 3. All right, so it's looking like we're okay, right? You got the third point in there. It kind of guarantees that you're going to have a straight line. Let's put 1, 5. So 1, 5, 1, 2, 3, 4, 5. And 2, 7. There's 2. That's 5, 6, 7. There we go. Yep, it sure looks like we've connected them. Now look, don't just go from the first point to the bottom point, okay? Make it go all the way through because it is a line. What does a line do? It keeps doing what? Keeps going forever and ever, all right? So we'll extend it out beyond the graph itself, okay? And just put some arrows on there just to show you that it does keep on going forever. So that's the graph. That was the question. They said to graph it. Boom, there you go. You've graphed it, okay? There's a lot easier way to do that, but that's one way to do it. Okay, what I want to see is this. I want to see some intercepts. Where is the y-intercept to this? It's where it crosses. Oh, I didn't say that word yet, have I? I got to say that word. Let me write it down. The y-intercept is where the line crosses the y-axis, okay? Where does it cross? Not at 3, because it's a point. You got to have an ordered pair. It's 0, 3. It's 0, 3, okay? That's where it crosses the y-axis, okay? So, watch this. Whenever x is 0, that's where your line is going to cross the y-axis. Did you hear what I just said? So whenever x is 0, so like right here, when x was 0, it told us what the y-intercept was going to be, right? How do you think you can find the x-intercept? What do you think?
Well, here it's probably
It probably will because it's in between. You're exactly right. So say it, Alex, what'd you say? When y is equal to 0, okay? So to find the x-intercept means when y is equal to 0. What does that mean? Look at this graph right here. Where on the y-axis does the graph hit 0? Right there. See that? See, here's the 0 right here on the y-axis. It crosses y-axis right there. So this is probably going to be a half, is my guess. I'm not sure if it is exactly. But to find that, well, let's find it. Let's find what the y-intercept actually is. I'm sorry, we just did the y-intercept. What the x-intercept is. So how would I find the x-intercept? Wherever it crosses the x-axis, but what's equal to 0? The y is equal to 0, exactly. So what we're going to do to set the x-intercept, or to find this x-intercept, we're going to set the y point to what? 0, okay? So let's come over here and do it, and let's see what it actually is. It kind of looks like it's negative 1.5, doesn't it? Or negative 3 over 2. Let's just see if it actually is. So what I'm going to do is take that original equation, y equals 2x plus 3, and instead of y, what am I going to put for it? 0 equals 2 times x plus 3. And let's find where the x-intercept actually is. I'm sorry. Yes, the x-intercept, where it crosses the x-axis. That's where I want to find. So what do? Well, I subtract a 3 from both sides, right? And then let's do it up here. So I've got negative 3 equals 2x, divide by 2, and that's exactly what I thought it was, right? Negative 3 over 2. What is negative 3 over 2 as a mixed number? It's negative 1.5. Look at that. So right there, that's our x-intercept. Okay? So that's another way. This is another. Yeah, this is going to be our second way to find or to graph something. And that way, you only got to graph 2 points. You don't have to put like 4 or 5 in there. Okay, you don't have to make up points. You just set either to find the y-intercept. Let's write this down. To find, let's go x first. To find the x-intercept, what do? You set y equal to 0. To find the y-intercept, what do? We set, what do you think? Come on, it's not that hard. To find the x-intercept, we set y equal to 0. To find the y-intercept, we set x equal to 0. That's right. Okay? So let me give you an equation that looks a lot different, well, a little different anyway, than what we did before. So I'm going to ask you to graph this using x and y intercepts. Okay? So here it is. It's 3x plus 2y equals 12. So I'm going to graph this using x and y intercepts. Watch how easy it is. I know the bell's going to ring, but just hang on for a second. So let's find the x-intercept. So what do? I set y equal to 0. So let's put a 0. I don't know why you're still talking. So let's set the y equal to 0. So I've got 3x plus 2 times 0, which is 0, right, equals 12. Let's do the math. What's that going to be? X equals what? 4. So what's my point then? What's my x-intercept? 4, 0. So that's one point that I'm going to graph. All right, and then let's find the other point that I have to graph. Let's do the x-intercept. So to find the x-intercept, we set x equal to 0. All right, so let's do that. Let's take our equation. 3 times 0 is what? 0. Plus 2y is 12. What's y equal to? It's 6. So my point is 0, 6. So I didn't dismiss you. I did not dismiss you. I dismiss you, not the bell. Sit down. If you don't sit down, nobody's going to lunch. Sit down. These are your 2 points. So here's how to graph it. 4, 0, 1, 2, 3, 4. You put a point right there. 0, 6, 2, 3, 4, 5, 6. Put a point right there at 6. You connect them. You try to connect them. I'm a little wiggly. That's how you graph it. Okay, look to see what your homework is on that lesson plan thing and get that homework done for tomorrow.